Hello friends, so in this video we are going to solve the Leetcode problem 740. The problem name is delete and earn. So basically let me read the problem statement first. So you are given an integer array num and you want to maximize the number of points you get by performing the following operations. And you can perform this operation any number of times. So what we can do, we can pick any number I and delete it. So whatever number we are deleting, we will get the value as points. And afterward, we have two conditions. Like, so basically, if we are deleting any number num I, we we have to delete all the other number which are equal to nums of I minus 1, and we have to delete all the numbers which are equal to nums of I plus 1. So we can perform this operation any number of times, and whatever the score we are getting in every iteration, we can add this to our score, and we have to find out the maximum score which we can get. So let me first explain you the problem using some example. So let's say we have an input array as 3 to 4. So this is our input. So let's take iteration 1. So in this iteration we are starting from 3, so we are deleting 3. So the, our current score is 0, we are deleting 3, so we are deleting 3, so 3 will be added to our score. And then we have two conditions. The first condition is, let's add 1 to 3, it will become 4, and we have to delete all the numbers from our array which are equal to 4, so we will delete this 4. The second condition is, subtract 1 from deleted element, and whatever value we get, you have to delete this number from array as well. So in this case we have to delete 2. So after deleting 3, we have empty array, so we cannot delete further, and the maximum score which we are getting now is 3. So let's see there is any other combination which gives more result than 3. So we are taking the same input array. So rather than starting from 3, let's start from 2. So in the iteration 1, so first our score is 0, and we are deleting 2, so 2 will be added to our score. After deletion, we'll add plus 1 to it, become 3, and we have to delete 3 from our array. We will take minus 1, and it will become 1, but we don't have 1 in our array, so we can ignore this. So after this iteration, we will have 4 in our input array. So currently our array is not empty, so we can perform second iteration here as well. In the second iteration, we will delete 4, and we will add 4 to our output. So what the total output we will get? 6. So in the first iteration we got plus 2, second iteration we got plus 4. Yeah, so this is the second way which we can do. Can we try some other combination as well? So let me start from 4. Let's delete first 4. We are deleting 4. So in score, which is currently at 0, plus 4 will be added. So after first iteration, we will minus 1 from this, will become 3. So we will delete 3. We will plus 1 to this, become 5. We don't have 5 in our array, so the first iteration, we will have 2 in our array and it's not empty, so we can perform a delete operation again. Then we will delete 2 from our array as well, and we will add 2 to our score as well. Now the score will become 6. So this is the another combination, but again it gives the same value as 6. So currently, let me discuss the approach which we are doing. So currently we are trying brute force. What we are doing, we are starting from every index. First we are trying from index 0. We are trying to get score by starting from index 0. Then we are trying to start from index 1 and get its score. Then we are trying for index 2 and get the score from this index. Then we are comparing all the 3 scores, and whatever gives us maximum result, we will going to use this. So this is the brute force one, and let's discuss its time complexity. So for discussing the time complexity, let's understand how it will work. So let's take, let's take this example, 1 3 5 9 and 11. Let's start from 1. After choosing 1, our array will reduce to 5 9 9 1 11. Then, so again, this is the same problem for us, and then in this we can start from 3, we can start from 5, we can start from 9. So basically we can have n-1 combination here plus n-1 combination here, n-1 combination here. So again, this is the same problem where we can solve starting from 3 or 5 or 9 or 11. Then again, we can start from 3 and then it will become, so for so this is the case 1 starting from 1, this is the case 2 starting from 3, and so on. So again, in this you can start from 1, you can start from 5, you can start from 9, from 11, and we will perform this operation until we get the 1 array is empty. So let's see how the pseudocode will, like for 1 to n. So this is for starting index, then we are trying for like for 1 to n-1, and again we are calling our recursive function here. So they will run in order of extra time, and we will have this will come as n time. So the overall complexity will be order of n cube. So let me show you the code for this. So yeah, this is our first loop. So I am not going in much detail. I will post the code there so that people can see, and if you have any doubt you can comment, ask in comments. So I will explain that part in more detail. So for first loop, we are starting from, like basically the first loop is checking starting from every index. It is calculating the final result or final earning which we will get, and we will return only the maximum one which we are getting. Then for every index, we are like checking its condition, current element, and then we are creating another array. So after performing the first deletion, whatever array will be there, we are storing this into this one. And for this array, we will have n minus 1 combination. So I am talking about the worst case. So in this worst case, we will have n minus 1 combinations that we are trying here. And then it will going to further reduce to n minus 2 and then n minus 3 and so on. This would be for first case. Like, so if you sum up n into n minus 1 plus n minus 2, it will become order of n square, and order of n square multiply by or n, it will become order of n cube. So yeah, so this is the worst case, and this is the brute force approach that will run into order of n cube time. How we can optimize this solution? So we'll, let's take our same as example like 3, 2 and 4. Like brute force approach, we start from I equal to 0 and go to n, and we try every possible solution. Let's think of 4. So who will going to replace the 4? So it will be either 3 or either 5. If we got 3, then we cannot take 4. If you taken 5, in this case as well, you cannot take 4. So for the case 3, 2, 4, if we know, like, let's see the example of 4. If we know the elements before 4, what we have taken, like did we taken 3 or not, or do we have result before 3? Let's call this t of n minus 1 and n minus 2. So yeah, so this one gives us like result till n minus 1, and this gives results till n minus 2. So yeah, so before 4, it will be all the elements I have processed which are lesser than 4, then I can take a decision for 4. Like do if I have to include 4, then I can include 4 only in n minus 2, and I cannot include 4 in n minus 1 because it will be equal to 3 in this case. So, and at the last index, whatever value I am getting max of these two, that will be my result. So yeah, so how we can make this structure in a way that all the elements before 4 are processed in this array before processing 4. B1 3, we have to ensure all the elements which are smaller than 3 should be processed before 3, so that we can take a decision we have to include 3 or not. So how we can make sure that all the elements of 3 are processed? One thing which I'm thinking, we can sort the array. Okay, after sorting, all the elements which are smaller than 3 will come first. Elements which are smaller than 4 will come first, and so on. Now see, if you have multiple friends of 2 as well, then after sorting, it will come at first. So actually our sorting will ensure all the elements which are smaller than t of n will be solved first, and we can make a decision on the nth element that we have to include the nth or not. So our algorithm will change, like first sort the array, then for every element I we get two parameters. One is t of n minus 1 and is t of n minus 2. And then check if we can include I in t of n minus 1. If yes, then add some to plus I. And if we cannot include in t of n minus 1, we will include into tn minus 2, and whoever gives us the max result, that will be the result till our n minus till the n. So yeah, see the optimized solution. So actually this is the code for optimized one, and let's take the example. Let's say we have 3, 2, 2, 4. So this is the case 1. Okay, so first we have sorted it, so it will become 2, 2, 3, 4, and so this is the sorting logic. Then we have started from I equal to 1, and we will go till the I equal to n minus 1. Actually we are maintaining two sum. One is previous, so and previous to previous. So for the first case, index 1, the previous one will become index of I minus 1, so basically it will be index of 0, and with previous to previous the index is minus 1, so we are taking this as 0. Yeah, so in the loop we will have three conditions. Case 1, where we have current is equal to previous. So if we have current is equal to previous, in this case basically we are getting the same element. Basically we have multiple occurrence of same element, so we can include this into our score. So basically what I am doing here, I am doing sum of this element many number of times. So let's see the case 2. So here I am taking sorted array. So if we have 2, 4, so the sum will become 4 here, but so this is our previous sum and previous to previous 0. So if you talk about this 4, we can include this 4 in our previous sum as well, because the difference between current and the previous element is more than 1. So this is the case second, where your difference between current and previous element is more than 1, then we can include this. Then there is third case. Then there is third case, which is like we have 2, 3, 4. So this case the difference previous, first we have calculated sum of all the occurrence of 2, then this is our previous sum, previous to previous is 0, Then in this case 3 we cannot include into the previous sum because the difference between this is only 1, but we can include 3 into previous to previous sum, which is 0. Then it will become previous to previous sum will be 3, and yeah, so basically I'm calling it a temp. We can include 3 in previous to previous sum because their difference is more than 1, and then our previous sum will become 4. So now our current sum so will become let's see the case third. Okay, so in the case third we cannot include our current element. So take the example of case third. We have to 4. So our previous is equal to 4, previous to previous is equal to 0, and current element is 3. So we can include 3 only into previous to previous, and so now we have two solutions. One is previous to previous. So whoever is the maximum, that will be our sum till the this index. So yeah, this is I'm doing this. So first I am calculating all the occurrence of new element, then we are adding to the previous to previous, and whatever is the maximum, that will become my current sum, and that will be the previous sum for next case. So yeah, this is the third case which we will have to handle. Let's talk about the time complexity. So the first we have sorted this array, so it will be n log n plus. So whenever we are finding the same element, we are iterating through the loop and we are incrementing our I. And here the same case wherever we are finding same element. So if you think more carefully, this will run only in order of n times. The overall time complexity will be order of n log n. So yeah, this is it for this solution. So if you like this, please like and subscribe my channel, and I will add more videos. If you want anything specific in more detail about this problem, then you can comment in the video.